Here we'll see how to call C, C++, and Fortran from Python. We'll compare their computational efficiencies through a speed test. A good programming language must be easy to learn and use, flexible and reliable, like Python. Python has many advantages: easy to learn and use, flexible and reliable, extensively used in data science, handy for web development purposes, having vast libraries support, among the fastest growing programming languages in the tech industry, machine learning, and AI. But here is a problem. It's slow. No, it's not slow, but very slow. There are some strategies for speed up Python programs, and we may have to use NumPy and SciPy for all mathematical operations, and always use built-in functions wherever possible. And if you have to write a script, then you may try to use Python. It is designed as a C extension for Python, which is developed for users not familiar with C. It's a really good choice. If you are using Python and try to use C portions more, then it can be faster. So it is a really good choice. But the best choice is create and import modules and functions in C, C++, or Fortran. You can make a program which is easily more than 100 times faster than Python scripts. We'll see an example. It's a speed test. Functions are implemented in Python, Fortran 90, C, and C++, and called from Python. We have two vectors, x and y, in Rn. Now, in the vector version of the code, and we are using built-in function like here. So it's m times called. The same dot product is made m times. For right side is a scripted version. And for each run, start with zero initialization, and here the component wisely the terms are added to get the dot product. So length n, m times. Okay, here for Fortran 90, this is a vector version, and along with v, and this is a vector version m times, and using built-in function dot product for the vectors x and y. Now this is a script version. Now start with 0 and add the component wisely to finish one dot product and m times. Okay, that is Fortran 90. And for C++, we use numeric library for vector operations by using numeric, and vector version of C++ can use inner product. In numeric, it is defined, and each one is making a dot product of length n, and here m times done. Okay, you have to put here extend C when the program is compiled using C++, and it is called from some module written in C. along with this addition, C++ compiler will add a blocks of header files so that once it is called from C function, then without any mistake or error, it can be smoothly called. So you need that. Okay. Now this is C script version. Now start with 0. Now length n, two vectors are now component-wisely added to this variable, and m times the dot product. Okay, that is C++. And C module can be written, but in C there is no vector version. But you can write it quite easily in C. Now this is Python using NumPy. This is NumPy dot product, and this is a vector version, and m times dot product. And this one is now the initialization for this variable, and here add component wisely to finish one dot product here. So it's a script version, and m times. Okay, after implementation, we now compile by using this shell script. In the beginning, we define libraries for Fortran 90 and C and C++. And these are compilers and also linking together F to py3. And now along with the option from F90 and F90 flex, and we are using level 3 optimization, and that is object, the shared object name, and using all F90 files. For C, now you have to make position independent code, and along with the same optimization level, and shared object is here. Now using all C files. For C++, are the same, except using C++ files. Okay, after compiling, now you can wrap up in Python. Okay, here, okay, NumPy, and you have to import the C types to call C functions, and to measure the elapsed time, we imported that one. And this is for importing the standard Python functions. Now for Fortran, it looks same as Python files. Just from the Fortran library, import every function, that's it. But for C and C++, you have to use CDLL and in C types packaging. That is dynamic link libraries, I believe. And by using this, the shared object file, this the objects are made. Okay, here now we choose the vector length 100 and million times. So from 0 to n-1, the x is made and y is a simple perturbation by 0.1. We'll try to make a dot product and 1 million times. In this case, length 1000. And we have one more case, but anyway. And these are printouts. And for Python, the calling has the same pattern. In the beginning, the time is saved in T0, and result is gotten from the Python vector version. And here, now we make a printout and along with the time, and one more time we measure the time and subtract from t0, so that is the elapsed time along with that result. Okay, that's the pattern. Now for Python vector version and scripted version, for Fortran vector version and scripted version. Now for C, we have only scripted version, but when you try to call C function, you have to give really good, nice arrangement for data type. Now, test GCCS is requiring these four four arguments. That is double arrays, and these are integers. So that you have to declare here for the function arg types. So input types is from NumPy C types library, and ND pointer, and type is double. And again, one more, and C types C integer, C types C integer. Then along with that declaration, it will be automatically converted for C program. And now after computation, the return. So you have to also give return type for the function. Here, return type is C types, C double, and the Python is expecting such a type as data is coming and is converted and saved into result. Okay. And so again, same pattern, we print out after measuring the elapsed time. For C++, we have two functions. One is along with V, and the other one is along with CS. So therefore, each one we have to declare this the input type and output type. Now, after defining this one, here you may use it. So rather than write your whole thing, 3 line, you may use that one. This equal that, you can use that. But anyway, after this declaration, we call and vector version and scripted version, and along with the elapsed time, print out the result. Okay, here we have the comparison. I'm using a Linux operating system with Intel Core i7 CPU at 2.6 gigahertz. When we are choosing the vector length 100 and billion times of dot product, the total number of flops is 200 billion for that. And now here, Python vector version, scripted version, F90 vector script, and C script, and C++ vector script. These are almost the same, with the Fortran about around 10% faster than C modules. And also the vector version or script version, once for these compiled modules, they are basically the same. But here for Python, okay, script version takes much longer time than vector version. So you have to use, if possible, we have to use built-in functions as much as possible. But yet, this one is more expensive than this one. Okay, now we'll go a different choice. Now the vector length is 1000 and 1 million times of dot product, so that we need 2 billion flops for this one. Now the same way, Python vector version, script version, and here F90 and C and C++. These are almost the same, and Python Fortran is slightly faster than C. And here, in this case, the Python and using the built-in functions is quite good, but yet slower than compiled modules. But now for script version, it's about 250 times more expensive than vector version. And we test another case. That is now back to vector length 100, and now this is 10 million times, so that number of flops required is the same, 2 billions. For this case, now we have the same output, and here you can see the computation time. Now these compiling languages have quite similar computation time. Now for the Python script also the similar, but somehow for vector version it takes much longer time, about 9 times more time. So from time to time, vector version of Python takes a much longer time than compiled the languages. But the script Python taking much longer time. Here we have summary. Not only this example, I tested some other operations, but I got quite similar results. So we have here summary. When we call C, C++, and Fortran from Python, we have these observations. Compiled modules are 200 plus times faster than Python scripts, and compiled modules are yet faster than Python built-ins, and Fortran is about 5 to 10% faster than C or C++. It must be. Fortran is designed for fast computation. If you are working on very innovative projects, then often the project requires a completely new code. You may search and try to download public domain functions, but if they are in C, C++, or Fortran, then you don't have to re-implement it in Python. Just you can call it from Python. If a function needs a long script, then rather than using Python, you should try C, C++, or Fortran. That's it. Thank you.